Imagine a house with no rooms. Now imagine another house with neatly separated rooms. Which of these two do you think is easily maintainable? If you thought the answer is the second one, you're on the right track. Hello engineers, welcome back. In this video, we're going to talk about the first principle in Solid, that is the single responsibility principle. Okay, let's get started. So as per the definition, a class should have only one reason to change. That's what the principle says. Now that doesn't make much sense, but let's try to understand it with some examples. So imagine there is a restaurant and there is only one person managing everything. So this guy is the chef and he's handling the billing, the cooking, the marketing, table service, cleaning and whatnot. Okay, clearly this guy is not happy, right? Because he's overloaded with stuff and it is practically unmanageable. So this is kind of a violation of the single responsibility principle. Okay, because a class should have only one reason to change, but here we are giving this person to have so many reasons to change. If there is any issue with billing, this person needs to be contacted. If there is any issue with table service, same person will be contacted. If there is any issue with the dish, same person will be contacted. As you can imagine, this person will be overwhelmed and this is not a maintainable situation. So how do we fix it? We split the responsibilities within the team. So the kitchen stuff and cooking will be managed by the chef and now the chef is happy. And another team will be managing the table service and one more person will be managing the billing and a bunch of other guys will be managing the marketing side of things. So we have distributed responsibilities now and this is a much better situation, right? And this is what we do to fix the violation of the single responsibility principle. So all that the principle is saying is don't bloat up your class, divide the responsibilities and keep the classes short and crisp so that they can be easily maintainable. Okay. Now this is a basic example to help you understand the concept. Let's get into the code a little bit. Okay. So I have two files here. One is the concept, one is the use case. So the concept file will give us the understanding of the single responsibility principle using a fun example like a robot. And then the use case file will give us an insight into a real world use case of how this principle is used, right? So let's look at it. So first let's look at the concept. Let's say we have a robot class and it has two methods, move and talk. And as you can see, we have created a robot object and we have called these two methods. Now, if I run this code, we expect that these two methods should be invoked. And as you can see, we have robot is moving forward, robot says hello world. But this is a violation of the single responsibility principle because all the talking related stuff is happening here. All the movement related stuff is also happening here. So if I need to make a change with respect to movement, I need to come and change this class. If I need to change something with respect to the speech, I need to come and change this class. So this class is having multiple reasons to change. So that's why this is a violation. So how does the fix look like? Let's have a look. So let's have a look at this code. Now we have moved the movement related stuff into a movement class. We have moved speech related stuff into a speech class. And now we can call upon these two objects independently and they can give the same result. Let's run and see. See, same result. But now this is a much more maintainable code. Why? Because if there is anything related to movement, I can change the movement class and speech class is not affected and vice versa. I can add more stuff here. I can add move, dance, run around and things like that. And I can add talk, sing, hum and anything else to this speech class, right? And they are now independent and they are much more maintainable. As you can imagine, I can also move these into separate folders or separate files and the code will still work the same and it is now much more easily maintainable. So that is the single responsibility principle. Now let's go into the use case file and see a slightly real world example, right? So let's say we have a logger class. A logger class is responsible for logging stuff, simple, and it has one method called log message and it is simply doing a cout to the console. It's logging message, whatever is the message coming into the function, it is just printing it. But it is also doing something else. It is saving the message to the file, which is a private method. So if I run this, you will see that the message is logged to the console, and there is a new file created that is called log.txt, and we have the same message logged to the file as well. So there are two different things happening here. One is logging to the console and another is logging to the file. But these are two different operations. So if I have to change anything in either of those methods, I'll have to alter this class. And that is a violation of the single responsibility principle. So how do we fix it? Let's have a look. Now let's have a look at this code. We have a separate class called console logger, which has one method log message, which will just see out to the console. And we have another class called file manager, which will have one method save to file, right? Now I can have individual logger objects and they will do different things and they are independent of each other now. Now if I run this code, I get the same message, system started, and if I look at the log file, I'll have two entries, system started. One was from the violation code, now from the fixed code, right? So the code works the same, but now these are easily manageable classes. Why? Because if I need to change any logic to the file, I can go to the file manager class and do so, and I don't need to bother the console logger class and vice versa. So this is a much more easily manageable implementation of the single responsibility principle. Okay. So I hope you got the idea behind the single responsibility principle. All that the principle is saying is divide the responsibilities and make your code easily maintainable. So that's all the single responsibilities and principle is saying. This is one of the easiest and simplest principles to understand and easy to implement as well. Okay. So I hope you've understood the first principle. I hope the examples have been intuitive enough for you to make sense of them. If you have any questions or suggestions, definitely put them in the comments and I will try to address them in a future video. Thank you so much for watching, guys. Don't forget to leave a like if you found this helpful. Do subscribe to the channel if you haven't done already. In the next video, we will look at the second principle, which is the open close principle. Okay. Thank you so much for watching. I will see you in the next one. Cheers.